continuity equation. It is related to mass rate of flow along streamline. Equation of continuity flow based on principle of conservation of mass. Bernoulli's theorem deals with conservation of yes, energy. Drag coefficient of laminar flow. This we have not covered till now. We'll see this thing later. Continuity equation of incompressible fluid flow. Now this you can tell quickly. 290 it is A. Now this thing will cover in next class. This one, general equation of continuity for 3-dimension flow of a compressible fluid for steady flow. Continuity equation 3-dimension for compressible steady flow. So continuity equation is dou rho by dou t plus dou u by dou x plus dou v plus dou by dou z rho w is equals to 0. Continuity equation, it is equals to 0 for steady, for compressible steady flow. For compressible steady flow. Steady flow means derivative with respect to time. It is 0. Now you tell. With respect to time, it is 0. So this will be 0. Now dou rho u by dou x plus dou by dou y of rho v plus dou by dou z of rho w. We have seen these things. This is the equation for steady flow. For steady flow, this is 0. Okay. So this is the equation. This is the equation. Okay. So which is the option? This is the equation. Which is the option? No, A also it is not matching. Rho is not there. For compressible, no. If it is incompressible, rho can come out from the differentiation. E. None of the above. No, none of this thing is matching with this equation. Okay. 375. Euler's equation. It is applicable for which assumption? We have taken Euler's equation irrotational. Irrotational was not there. That consideration was not there. Whether it is, see, you should take in, you should see in with respect to inviscid, incompressible, and steady. Okay, so flow is homogeneous and incompressible, then it is applicable. Along a streamline, that is not a means, it is an assumption. It will be there. Okay, flow takes place continuously, then only you can apply. That is also not a correct thing. In turbulent flow, anyway, turbulent flow should not be there. We have neglected that turbulent part. And irrotational was not the criteria there to consider the equation. Okay. Now, Euler's equation. Which one is the Euler's equation among this? You can remember from your Bernoulli's equation, this thing. P by rho G plus V square by 2G plus Z equals to constant. So if you write this in differential form, you can write this as dP by rho plus G I will take here. So V square you can write V dV. V dV integration is V square by 2, and then plus G dz equals to 0. So it is matching with this one. C is the answer. Okay. 377. For irrotational flow, this is the equation. This equation is given by 377. Yes, it is Laplace. We have seen, no? For irrotational flow, if it is if it this velocity potential function, if it takes this form, then it forms, sorry, the irrotational flow, if it is satisfying our this thing continuity equation, then it takes the form of Laplace equation. This is the equation for yes, it is 3-dimension, but also you should remember this is equation for which line? No. Streamline. Equation. 3x by u plus dy by v, sorry, not plus, equals to dz by w. This is equation for streamline. This is three dimension. It is correct for 3 dimension. This is okay, but you should remember that this is also a equation for streamline. That's what I was asking. This is okay. Answer is 3D. Okay. Okay. Stagnation point. This though I have already explained. Na? Continuity equation. See, this is pressure P, not density. Density is this one, rho. So P1, A1, V1, it cannot happen. It is A1, V1 equals to A2, V2. This is the correct one. Okay, continuity equation. It is related to same only, related to mass flow rate. This also same, continuity related to mass flow rate of this is same thing only. This will cover in next class. Bernoulli theorem is applicable for actually it is applicable for steady flow and incompressible both. It is applicable for steady flow also and incompressible flow also. Okay. When venturimeter 463 venturimeter is inclined, then for a given flow reading, how it will be this reading? Yes, it is same. I have explained this point already. Quickly we'll solve 3-4 more questions. Quickly. This one. This anyway I have not told you, but okay. This in this case, see, we have actually to measure flow rate, we have venturimeter, orifice meter, then there is nozzle also. Okay, and then there is rotameter also. Okay, and for velocity it is pitot tube. So actually when you compare these three, this is the most accurate one. but nozzle also it is having similar accuracy, not much. Where most accurate is this one only, venturimeter. Okay, but this is also having similar accuracy. But the thing is, why we do not use venturimeter? Because its cost is too much. Okay, venturimeter cost is too much. Nozzle, making nozzle is easy, but venturimeter, this one, then divergent part, all these things making is very costly. So venturimeter is costly. Okay, its accuracy is similar to nozzle only. Okay, but means if you see the reading wise, this is the most accurate, but this reading is also near to this. But the cost of venturimeter is very high. Okay, it is it is more. So this is see, venturimeter is more accurate than nozzle, but this also is correct. Nozzle has same accuracy as venturimeter, almost same, but pressure loss is more and cost is low. Here pressure loss is more and cost is also low compared to our venturimeter. Okay, so more accurate will be this only because it is having similar reading only. Okay, 461, 461, rotameter flow, rotameter flow. Okay, this is equation we need to calculate. Okay, we'll do it in next class then. Tomorrow morning, are you available? 9:30. We'll start our class tomorrow 9:30. No, means actually tomorrow evening I have to go to office actually. Urgent work is there. Otherwise, I would have preferred evening only. But that is the problem. Otherwise, I would have taken the class in the evening only. Sorry, huh? Okay, then we'll end the class now. Thank you. Good night. Second half means my class timing was 12:30 to uh, like 2:30, but I have changed it to 9:30 to 11:30. I have switched like that. Morning will have class at 9:30. Someone else will take, I think, at that time. Okay. Okay. Thank you. Good night. I'll end the meeting now.